Hello everybody. I'm going to present our paper design of multiband fractal antenna for energy harvesting applications. The authors of this paper is Ahmed Sabawi, Qusay Sultan and Muhammad Salim. All authors are from the College of Electronics Engineering, Nineveh University from Mosul, Iraq. The paper has been accepted to be published in the International Renewable Energy Congress IREC 2020 in Tunisia. Introduction. As we all know, with the recent advancement in wireless communication system, robotics, and Internet of Things, many researchers are paying a lot of interest to addressing the power consumption of these systems. And there are lots of efforts in order to find a power source for this system for powering up the electronics or for charging batteries. One of the possible solutions to provide another means of power or another power resources is the energy harvesting or the radio frequency energy harvesting techniques, which involve harvesting energy from ambient environment for powering up the system and charging the batteries. And as we may all know that there are lots of available communication systems around us, and we are exposed on a daily basis for many electromagnetic waves from coming from different communication systems. So harvesting energy from various mobile networks means dealing with several frequency bands, which include but not limited to digital broadcastings around 750 megahertz, GSM 900 megahertz, DCS around 1700 or 1800 megahertz. We have also LTE networks around 2 gigahertz. We have WiMAX also around 3 gigahertz. We have the coming technology of 5G mobile networks, let's say the sub 6 gigahertz from 3 up to 5 or 6 gigahertz. And we have ultra wideband applications at 4.2 gigahertz. And we finally have the IEEE 800 02.11a WLAN and LTE band 46 from 5.1 to 5.9 gigahertz. So we have many communication systems. We have many base stations. We have many transmitters. All of them are transmitting electromagnetic waves at different frequency bands. So the idea is to harvest energy from all of these free sources or all of the available electromagnetic wave or microwave signals in the air by receiving them using an antenna, then apply it to a rectifier to convert from AC to DC to provide or to obtain a DC power sources. Uh, One of the main ideas or the main idea of this paper is to design a multi-band or broadband antenna to receive as much as we can from these available signals in the air. So one of the solutions is to use fractal antennas. But before we go to the fractal design that we use in our paper, we would like to show that fractal shapes are available around us in nature. So by saying fractal shape, which means that the shape repeating itself exactly in identical way, but with a smaller size. So it's a repetitive uh, shape inside each other, but with smaller size. So this kind of shapes or fractal shapes, if we use it in antenna applications, we can come up with a multi-band or broadband antenna. And for the subject of energy harvesting systems, we need a dual band, triple band, or a multi-band antenna to receive as much as available energy as we can. So in this paper, we have used a fractal loop antenna based on the second iteration of a 9 side polygon fractal shape. We used only single loop. We used CST Studio software to simulate the designed antenna, which is designed on a FR4 substrate with dielectric constant 4.1, loss tangent 0.02, and a thickness of 1.6 millimeter. And this proposed antenna have achieved dual band performance. As we can see here from this slide, that the S11 or the S parameters of the design antenna, we can see that the antenna is resonating at two frequency bands. The first one is around 900 megahertz, and the second one is around 4.2 gigahertz. And also, the antenna has achieved a good radiation characteristic with a gain of 2.7 dBi and an efficiency of 99%. And the radiation characteristics also are very good and acceptable, as the radiation pattern, as you can see here, that it has almost omnidirectional radiation pattern, which is preferable in this application. We need to design an antenna that has a good matching with as much as less losses as possible, and has omnidirectional characteristic that that can receive signals from all around, or from all directions. However, as you can see, it has only two bands, or it operates only at two bands. But as we said, we have so many frequency bands available around us, so we'd like to increase the frequency bands of this antenna. We came up with the idea of inserting another fractal loop inside the original one. So we have a double loop fractal antenna. It has two fractal loops, the outer one and the smaller one, which has been inserted inside the original one. This idea, or the goal behind this idea, is to increase the number of frequency bands. So the new modified fractal loop antenna is expected to operate at a multi-band operation. And as we can see here from the reflection coefficient, or the S parameters of the newly designed antenna, that it actually operates at six frequency bands. The first one at 765 megahertz, the second one around 900 megahertz, the third one is 1.74 gigahertz, the fourth one is around 3.2 gigahertz for the 5G, the fifth one is around 4.2 gigahertz for the ultra wideband applications, and the final one is around 5.8 gigahertz, which can operate or which can receive signals from 5G base stations, or even the IEEE 802.11a wireless LAN applications. So for in this case, where we have successfully designed and simulated a double fractal loop antenna that can work at six different frequency bands with very acceptable radiation characteristics. So this designed antenna is a good candidate for energy harvesting applications. And this work can be further developed by fabricating the designed antenna and integrated to a DC to DC rectifier, AC to DC rectifier, in order to measure the harvested power from the system. Thank you for listening. If you have any question or inquiry, you can contact me on the email that is written on the first slide of this presentation. You can please email me at ahmed.sabawi@universityofnineveh.edu.iq. Thank you so much.